everyone, this is Teja. Now I am going to explain about the concept of measures of central tendency. Central tendency measures are three types. One mean, second mode and third one median. Now first we know about mean. The arithmetic mean of dataset is the sum of all values divided by total number of values. It is commonly used to measure the central tendency because all values are used in the calculation. And the second one is median. The median of dataset is the value that exactly in the middle when it is ordered from low to high. In larger dataset, it is easier to use simple formulas to figure out the position of the middle value in a distribution. We use two different methods to find the median of a dataset, depending on whether the total number of values are even or odd. And the third one is mode. The mode is most frequently occurring value in the dataset. It is possible to have no mode, one mode or more than one mode. And the mean are three types. First one, arithmetic mean or mean in ungrouped data. If x1, x2, x3, so on, xn are the set of n values of variables in the arithmetic mean is given by x bar is equal to x1 plus x2 plus x3 plus so on xn by n, that is equal to summation of xi by n. In case of frequency distribution, f1, f2, f3 so on fn are the frequencies of x1, x2, x3 and so on xn, then x bar mean is given by f1 of x1 plus f2 of x2 plus f3 of x3 so on fn of xn by sum of the frequencies f1 plus f2 plus f3 plus so on fn, that is totally given by summation of f5 xi by n, where n is equal to sum of frequencies. And the second one is deviation method. It is also called as shortcut method. If we see here an example, x bar is given by, that is mean is given by a plus sum of fi di by n, where di is xi minus a. Here a is any arbitrary point. And the third one is step deviation method, that is worked on grouped data. And the mean x bar is given by a plus summation of fi di by n into h, where di is equal to xi minus a by h. Here a is any arbitrary point, h is equal class in interval. If we consider examples on ungrouped data, the following are the ages of 15 employees of a manufacturing company. Those are 65, 38, 52, 27, 24, 45, 49, 50, 26, 37, 44 and so on. To find the mean, here sum of xi values by n. Here these are the xi values and total n is 15. If we calculate those, we get 43.23. Now for frequency distribution, here is the example. X bar is equal to sum of fi xi by fi. Here x values are multiplied with the f values and those are sum and divided by frequencies. We get 4.09. If we consider the grouped data to calculate the mean, here these are class intervals and this is frequency. Here we use a step deviation method and di is calculated by xi minus a by h. And then here we find n value, that is summation of frequencies, and also we find summation of fi di value also. Now here a is equal to 28 and h is equal to 8. From step deviation method formula, we get mean x bar is equal to a plus sigma fi di by fi into h, that is equal to 28 plus and so on. We get 25.4. And the second one in central tendency is median. For ungrouped data, median of distribution is the value of the variables divides into equal parts. Median reflects in the middle value when the observation ordered from least to most, that is low to high. The median is the middle value after values have been arranged in ascending or descending order of magnitude in the case of ungrouped data and number of observations of order. Add in the case of even numbers, there are two middle terms in the median is obtained by taking the mean of middle term. In the case of grouped data, continuous frequency distribution is given by median is equal to L plus n by 2 minus Cf into H, where L is equal to lower limit of median class and F is equal to frequency of median class, Cf is equal to cumulative frequency and H is equal to height of median class. Here we consider the example problem on ungrouped data. To find the median for the following data, and here are the two observations. First, we need to arrange the numbers in ascending order or descending order. Here we consider ascending order 6, 8, 9, 10, 11, 15, 20, 25. Since there are 8 numbers, the median will be average of middle two numbers when numbers are arranged in ascending order. So the median can be the average of 4th and 5th number, that is median is equal to, here 10 and 11 are the middle value. So 11 plus 10 by 2 is equal to 21 by 2, that is 10.5. And for next one, arrange them in again ascending order 3, 8, 10, 18, 29, 33, 49. Since there are 7 numbers, the median will be median will be middle value, because here the 7 values, those are odd numbers. So the middle one is the median, that is 4th number, median is equal to 18. In the case of grouped data, here is the example. Calculate the median of following frequency distribution. These are the x values and these are the frequencies. Here we construct a table for cumulative frequency, and n is equal to, we know that sum of frequencies, n by 2 is equal to 104 by 2, that is equal to 52. So the median is 5. Steps are involved. These are the steps involved, and we find the answer. And the third one is mode. Mode for ungrouped data. Mode is the value which occurs most frequently in set of observation. In the case of discrete frequency distribution, mode is the value of x corresponding to minimum frequency. But in the case of grouped data, continuous frequency distribution mode is given by mode is equal to L plus F minus F1 by mod of F minus F1 plus mod of F1 minus F2 into H, where H is equal to height or width of the class and L is equal to lower limit of class. F1 is equal to frequency of model class. F1 comma F2 are the frequency of preceding class and succeeding model class. Here is the example problem on ungrouped data. To find the mode, these are the values 60, 64, so on. These are our required data, and the solution mode is equal to maximum frequency. Here 64 is obtained for 1, 2, 3, 4 times. So maximum frequency we have 64. So 64 is the answer. For grouped data, here we have a table, cumulative frequency, class interval and frequency. We construct a table, and to find the mode, here is the formula. We substitute these values in the mode formula for grouped data. So next, merits and demerits of central tendency. Merits. Central tendency measures such as mean, median, mode offers several merits in statistical analysis. These are one simplicity, representation, usefulness, and demerits are sensitivity, limited representation, and distorted.